Next up is something which is going to discuss the decentralized ledgers and the decentralized ledger technologies. The thing is that currently we see that there are these kind of scaling issues with blockchain or Bitcoin, Ethereum. We see that there is a technology and protocol war going on. And currently there is this protocol war and standard war going on, and we will see which kind of technologies will survive and which one will die. And about that, we will have Piers for Ridyard, or how do I say? Ridyard, Piers Ridyard from Radix Global on the stage. He's a great guy, has a red head, and is late. Okay, shoot.
Hey guys. So yeah, my name is Piers Ridyard. I'm the CEO of Radix. Thank you for that lovely introduction. So before I start my talk, it always feels weird to do this, but never in the history of technology has it been possible to so directly bet on technology that I have to give a disclaimer and say none of this is investment advice, and don't make any financial decisions off the back of this. So today, I am going to be talking about protocol wars, which is like Star Wars, but even more geeky. So in light of the original series, I am going to be talking about three things. The first is the past, where we've come from, A New Hope, what the rebellion looks like. This now, centralization strikes back, what's being done to try and solve some of the problems that have emerged and what those problems cause themselves. And then the Return of the Jedi, where we're going, what I think is going to happen in 2018, and sort of what's looking forwards beyond that. So, the rebellion. The year is 2008. And a group of people from the cypherpunk forum and mailing list are discussing a new idea by Satoshi Nakamoto called Bitcoin. And the idea was simple. It's like, how do we create money in a way that is incorruptible, that is unstoppable, and that is anonymous? And that last idea was a really important one. And the reason it was important is if you look at the Cypherpunk Manifesto. The Cypherpunk Manifesto says, faceless companies and governments will not protect the identity of the individual. It is up to us, the people who create code, to create ways of protecting that for ourselves. Cypherpunks write code, and they will write the code that does that for the individual. But there's also parts of, I'd say, there's some other parts of that as well. The first is the libertarian ideal, which is that what's mine is mine, I'm the sovereign of me, and if it's my property, I get to choose what I do with it. The second is a sense of injustice, right? We have the federal government at this point, 2008, bailing out the banks. And that's actually a tax on everyone's money, because they're printing money. And the way that works is quite simple. If we say that there's a fish, and I got 3 gold coins, I got 1, you got 1, and you got 1. And let's say that the cost of the fish is the fish divided by total currency supply, right? So it costs a third of a fish costs 1 gold coin. Now, if I've got a lever here that allows me to print money, more gold coins, and let's say I print 7 more of them, and the fish stays the same maths, right? So it's now 1 fish divided by 10 coins in circulation. I can buy 8/10 of the fish, and you guys can only buy 1/10 of the fish. And that's essentially what the problem that Satoshi Nakamoto was trying to underpin with this ability to inflate currency supply, but not distribute it, and keep it and then give it to the banks and bail it out. So there's a sense of injustice around how money could be controlled by central authorities. And then the last thing was there was a challenge. Like, the idea of building something that you can create digitally unique objects that you can transfer from one person to another, and that there is no central authority to validate that transfer, that's a really big challenge. That's a really interesting technical thing to try and solve. And that Noscent is a really important idea. That comes into the idea of things like anti-fragility. So if there's no center, there's no one place to attack it. That comes into the idea of it being unstoppable. And it also allows this sort of to percolate around the world very, very securely. But it has a problem, which is that Bitcoin fundamentally doesn't scale. In fact, blockchain as an idea, as an architecture, doesn't scale. And the reason it doesn't scale is actually quite simple to explain. You have a blockchain, and it's a synchronous system, which means that everyone needs to be synchronized up, right? So if I have a node in America, I have a node in Iceland, I have a node in Australia, we all need to be working off the same hymn sheet. We all need to be singing off the same ledger. And so you have a physics constraint. This isn't like a theory, this isn't something you can just push up, but a physics constraint based on the speed of light and the speed of internet connectivity between those points. And practically speaking, at the speed of the internet today, that's about 500 transactions a second if you're working on a pedigree blockchain, you remove the block size limits. And then after that, it falls over. You start getting something called block thrashing. You can't push it up any more than that. So that causes this issue where you're like, OK, what we want is the TCP/IP of value. We want the next layer of the internet, the trust protocol that sits on top of it that anyone can use. But if you've only got 500 transactions per second possible to put through it, and everyone has to share that, suddenly that's looking a little bit flimsy because, if Visa on its own does 2,000 transactions a second on average, and everyone has to share it. And you saw this problem with Ethereum and CryptoKitties, where Ethereum currently does 20 transactions a second, and CryptoKitties was putting 12 transactions a second, and everyone else had 8 transactions a second to share, and that wasn't enough. And suddenly you had to wait your turn to join the ledger. So how do you solve this is the question that is currently at the base of all the protocol wars today. And I'm calling this part Centralization Strikes Back. And ultimately, if you win the protocol war, the thing that is at stake is huge. The prize is huge. There's a book called Capital in the 21st Century, which is a really good read. I'd recommend it to anyone. But it estimates that of the average rich country GDP, 50% of GDP, gross domestic product, goes to the allocation of capital, and 50% of it goes into labor. And the allocation of capital fundamentally is something that's going to be disrupted by blockchain. So you're looking at 50, or distributed ledger technology. So you're looking at 50% of an economy potentially going through this ledger. So that's a big prize. And it's incredibly well-funded as a result of that. You see ICOs in this space all the time. So there's 4 tools that people are looking at as a way of solving it. First is to chop it up. The second is to centralize it. The third is to take some of the work off-chain. And the fourth is to drop blockchain as an architecture altogether and try something else. So the first thing, chopping it up. This is a simple idea. All you do is you go, OK, if I have one blockchain, it can do 500 transactions a second. What if I just make lots of blockchains and have them working concurrently? And then we can multiply that by how many? So if I have 1,000 blockchains, then I can do 500,000 transactions a second. The problem is that you still need to make sure that no one's telling porkies across those blockchains. So if I'm on shard A, and you're on shard C, then we need a way of moving between those shards, and we need to make sure that no one's lying between it. So what you actually do is you put a blockchain above the blockchains, a blockchain of the blockchains, right? Blockchain inception, if you will. And that chain still has that limit, right? Still got that 500 transactions per second limit. So while you're increasing the number of transactions per second you can do, you still have this upper scalability threshold that's being caused by the blockchain of blockchains. So then the next stage is to go, well, what's our limit? Our limit is internet connectivity and speed of light. So what if we just bring those, the ones that are working on the blockchain of blockchains, what if we bring those closer together? What if we put them all in big data centers with great internet connectivity between them? Even better, what if we put them all in the same data center? And then we can get it working even faster, and we'll make that the master chain. We'll make that, and we'll make sure that our nodes that are telling everyone else what the consensus is, the master nodes. That sounds like a good idea. Problem is you've just gone back to your centralization point in the first place. And you still haven't fundamentally solved the problem. Yes, you can make it go faster. So maybe you can get 1,500 transactions a second, which is what Ripple's doing on that master chain. But you still haven't pushed out, you haven't got rid of this synchronicity problem. The third idea is take it off chain. So let's do state channels, and they've got cool names like Lightning and Raiden. And this is a really cool idea. I like the Lightning network. I like the Raiden network a lot. The idea being that you can sort of reserve a state on chain, go off chain, do a load of things, and then share the end state again, and then that's auditable. And so everything you've done off chain is reported back to chain, but you can do loads of transactions in that state channel, right? So you can take a load of the things that you were doing on chain and put it off chain, but you still have an immutable record of truth. The problem is that, well, there's a number of problems with it. One of which is that you're actually bringing centralization back again, because the way that you choose who you're opening state channels with, you'll tend to choose it with people who are very large aggregators of state channels. You're also not able to do things like smart contracts in an interesting way, because you have this end-lock time period, and that's not normally very long. So if you want something, a life insurance contract or something like that on chain, you can't really do that effectively. So they're really interesting, and I think that a lot of things may be going that way, but you still have this fundamental issue, which is that your state channel starts and ends on the blockchain. So even if we scale up, and we keep scaling up, and we get to the point where we're putting loads of stuff through state channels, you still have this issue of waiting to open your state channel and close your state channel on the blockchain, which ultimately gives you this upper scalability limit still. So what else is there? Well, people are looking at DAGs, directed acyclic graphs. It's a cool idea. Different companies call it different things. IOTA calls it a tangle, it's a DAG. Rayblocks calls it a block lattice, and it's sort of similar. There are some differences, but it's essentially a DAG. And a DAG is an asynchronous network, right? So you can put things through without having to wait for a block. The only thing you have to wait for is another transaction that you can verify, right? So you're like, your work is, I want to do a transaction. I put my transaction forwards, but to be able to do that transaction, I have to verify 2 other transactions. So your work is actually increasing the throughput of the network, which is awesome until you get to the point where you have to hold the entire data set. So yes, you can push it over. You can get to 2,500 transactions a second. But you get to this point where you physically can't hold all of the data set on one server unless it's a really powerful server. And so then you go back to this idea of coordinators and centralization, which causes a problem again. And my favorite analogy to why centralization is bad is sort of the Death Star. It's really powerful, but if a flaw is found in it, then it blows up and kills the entire the entire evil empire. So going forwards, what is going to happen next? So there are lots of companies who are trying to solve this problem. My company is one of them. We're looking at ways of allowing large scalability without centralization. But someone will solve this. What I think is really interesting is what's going to happen next. Once we've got this protocol layer that everyone's like, okay, we've fixed that problem, what does it mean for the world now? And money isn't the only thing, right? There are lots of other things you can do on blockchain. There are lots of other things you can do on DLT. But money's the hardest problem, which is why people are kind of looking at it and going, well, if we solve this, then everything else sort of follows. So what is there? There's identity. So if there's a whole host of lies that you can't really tell on a blockchain, on a DLT, one of which is pretending to be someone you're not, right? You have PGP encryption, pretty good privacy encryption, which is a key pair. And your public key pair is what a lot of you will be aware of just calling it your wallet address. And anyone can prove that they own a wallet address simply by signing a transaction, right? So it may not be that you're proving you're you, but you're proving you control that wallet address. And as soon as you have that, identity becomes a really interesting idea, because you could have other people sign attestations to it. So I could have the government sign an attestation to my public address and says, this guy has a passport. I could have a bank sign an attestation to a public address and says, this guy has passed AML and KYC for our bank, right? And suddenly, I can prove at the click of a mouse that that belongs to me, and therefore you can trust me. Sovereignty is a really interesting concept. If you start putting our governments on blockchain, on DLT, if you start putting the systems in which we pay our taxes on DLT, they start to become a lot more auditable, but does the concept of the nation state become more malleable as well? Can I become a citizen of a decentralized autonomous organization where my money is going towards that and we have a set of rules as to how it looks after me? Communication. Now, people keep saying, oh, internet is dead. Internet is dead. Internet's not dead. Keep saying that email is dead or is a dying medium. The thing about communication with blockchain or DLT is that your public key is also a way of me sending encrypted messages to you and only you being able to decrypt them, which is super interesting as well because now we have end-to-end security that we can be absolutely certain of. So our communications can be completely private. We don't have to worry about governments listening in on them. We don't have to worry about our data being taken by centralized companies like Facebook or WhatsApp or something like that. There's also things like property rights that can be put onto blockchains and DLTs. So I own my house, and then that house being something that I can prove that the government, instead of having it on a centralized database, has it on an immutable ledger. Now, for places like England or Latvia, that doesn't seem like something so revolutionary. But for places where autocratic governments can come along, being able to have an immutable ledger of truth and saying, I own this land for peasants and farmers, that starts to become really interesting as well. And simple things like achievements. You graduated university. You have your A-level results, you have your GCSE results, you worked at this company. All these kind of things can also be put on blockchain. Suddenly your ability to lie, your ability to cheat becomes a lot less, and your ability to authenticate becomes a lot more. But what will 2018 hold? 2018 is going to hold, I'm going to say 4 things that I think are going to be themes for 2018. The first is, I think it's going to be the year of blockchain for X. We have this problem that I was talking about before of scalability. So if you're saying, well, if I have to share my chain with other people, I've got this issue. But if I create my own chain for my own ecosystem, then I can have the blockchain of dentists, or I can have the blockchain of yacht building companies, or I can have the blockchain of pediatricians. And suddenly, you're going to see this coming out more, where they're going, we've worked out our own incentive mechanisms that work particularly for the industry that we're focusing on, and we're building our own blockchain for that. I think it's going to be the year of betting. I think this is also going to cause some regulatory headaches. We now have these crypto assets, and they're quite widely distributed, so I think people are going to start betting on things with them. Either esports or future events, like so Augur and Gnosis are 2 future betting markets, which sort of got a lot of press a few years ago. But I think that this is going to become something, a medium that people use for betting quite a lot, and that's going to be something you'll see coming out this year a lot. It's the year, I think it's going to be the year of collateralization. People are now accepting that these assets are real assets that have value. So a Bitcoin is worth something, and Ethereum is worth something. And so people will start going, okay, well, we can leverage these assets. So what if we put this asset as a collateral and we create a derivative instrument? Or if we put this asset as a collateral and we create a lending instrument? I don't want to sell my Bitcoin because it might go up. Okay, well, then just put it as collateral and I'll give you fiat against it, right? And the last thing is, I think it's going to be the year of government projects. I think governments are really interested in this area, especially places like the European Union, where you have 28 member states, I may have got that wrong, but 28 member states who all have to share information continuously, and there hasn't been a good way of coordinating that. But I think that you're going to start to see things like that being done more and more by governments. Estonia is someone who's already been trying identity card systems with blockchains and DLT. And I think that actually governments really like the idea of an immutable source of truth that can be distributed amongst other parties that they see themselves as equal to. So those are my predictions for 2018, and I will open the floor to questions. Yeah? Yeah, I'm done.
Excellent. I was a little bit surprised. This came very suddenly. I'm done. Thank you. Why didn't they applaud to you? Like?
I said I'd open the floor for questions, but
okay. The thing is, I was actually not thinking that I'm going to give you any time for questions because you were fucking 10 minutes late, man.
That's true.
But let's do it like this. If you promise to give really short answers, I will get one question out of the audience who raises their hand first. Like, this is the Baltic audience. They don't ask questions. Okay. Like, really, nobody. Yes, ask a question. Why the blockchain is going to impact energy?
Massively. Because you have this, like, we can create energy anywhere, and you can share, and you can create a peer-to-peer network of energy producers and energy consumers. I think it's going to be huge.
Excellent. It's going to be huge. Done. Thank you very much. You were such a great speech.